Hello everybody, my name's Walter, and today I want to show you how you can design and build contraptions based on my simple and cheap two-tier piston design. So the goal of this tutorial is not showing you how to build one single and more or less perfected contraption, but instead how to use a concept and build your very own designs for whatever you need. So let's give you an example. I have this 4-high door here, partially made out of slime blocks, and by clicking the lever here, the door completely retracts, the vault opens, and if I flick the lever again, the entire thing closes up again. And that's the basic idea behind it. Now as you can see here, this is a rather modular design for the doorways, or for the moving parts, and a very compact design at the very bottom here, plus this little pulse producer here up there, which is a very compact thing, a way to build this part, and actually rather simple to design. So anyway, this tutorial will be in two parts. In the first part I will talk about the mechanical side of the entire thing, how to design it, what you have to keep in mind when you want to do this, and then I will talk about the variations of the control circuit and what you have to keep in mind when you are designing those. And at the end of the tutorial, as I already mentioned, you should be actually able to design your very own variations of this. Okay, so let's start with the basic idea behind the entire thing. Basically we have two tiers, one tier at the back and the second tier at the front. This second tier is where the actual movement of the blocks we want to move happens. For example, those door components there. And since this piston only has a movement range of one block right in front of it, we use this first tier to reposition the second tier piston so it can reach the full movement range of the entire thing we want. So now how does this work? Basically we use very short pulses to get this piston to expel or retract the blocks in front of it, and then we use an analog signal to activate the pistons in the first tier piece by piece, or piston by piston, so that we can actually reposition this second tier piston every time it has moved. So, and just for a little demonstration, let's say we want to activate the entire thing, so we give it a very short pulse, then we activate the piston in the first tier, and then we give it another short pulse. Now we have expelled this thing here by 2 blocks basically, and the opposite direction basically looks very much the same. So this is the general idea behind it. Now let's talk about the maximum sizes of the entire thing. Due to the push limit of pistons of 12 blocks, the second tier is limited to 6 sticky pistons and of course 6 slime blocks, plus the sticky piston at the top here, which is basically the second tier piston. This is the maximum size, and this makes a movement range of 7 blocks in total for the blocks in front of it. Of course, you can reduce the size of it, and that even gives you more slime blocks you can add in this whole thing here. So you can go around corners, or you can even add more second tier pistons if you just need 2 sticky pistons right next to each other due to the way your actual contraption should work. But anyway, this is up to you basically, but this is just an option you have, so you can, if you have less than 6 blocks, 6 pistons at the back here, have a few blocks over to go more or less crazy with that. So anyway, that's the maximum size, so you just have to keep in mind that the block limit for those pistons still exists. Next subject is the actual powering of the first tier. As I already mentioned, we're using a analog signal for this, and this analog signal is fed into a stairs of blocks with redstone top that's going upwards or downwards. What you use depends on what direction you want to move. So an upwards facing or an upwards going stairs is used for upwards movement or sideways movement, and the downwards going is also used for a sideways or for a downwards movement. Now there are a few things you should keep in mind for those designs. For this upwards movement design, as you can see here, I have an extra block further up, and I don't have the comparator right next to this block here. The reason is we need this straight redstone line here going directly into this block, otherwise this whole thing here will fail to work as it's supposed to. And you also don't need any redstone on top of the last stairs block, although all of those blocks here must be obsidian or other immovable full blocks. The way this works is basically the redstone going into the block powers the block it's facing into. And this is also the reason why you need the extra straight line down there and no redstone on top of this one here. Now the downwards going stairs is a bit different since it powers just the block where the redstone is on top. And also here you don't need any straight stairs at the top, but it's actually easier to power it like this. Of course it's also possible to put the comparator down up like this and then a block here. But this is basically up to you how you want to design this. So now with the first tier out of the way, let's talk about the second tier, which needs short pulses. And in combination with that, I want to talk about a few piston bugs that are sometimes involved and will break your circuit or your mechanism. And I actually was able to find 2 examples for this. So as you can see, this concept or this contraption here will produce 1 tick pulses which are directly put into those 2 pistons here. And as you might know, usually those blocks here should be expelled. But if I power it, as you can see, those pistons just extend and then retract again. So it did not work as it was supposed to. And the reason here is rather simple, yet annoying thing that was, I believe, introduced with 1.9 or 1.10. And that has to do with update orders and such things. Basically what happens is that the piston down here gets power from all 3 of those blocks here, and due to the update rates and another few things, basically what happens is that it detects not a 1 tick pulse but a pulse that's a bit longer, and such a pulse will not expel the actual block here. Similar it's here, since it gets the power from this redstone line here and but power from this block here. And another thing comes into play here, and that is that this block here is directly powered and strongly powered by this repeater here, which means that in theory at the same time this piece of redstone and this piece of redstone get powered, and again due to a bit of Minecraft confusion this results in a pulse that's a bit too long. But this is a very position dependent bug and it does not appear in all positions, but the chance that they appear rises extremely with the size of your contraption. So how do you avoid those problems? So let's talk first about a sideways contraption. Basically what we want in both cases is to avoid powering a piston from more than one way, and at the same time we want to avoid powering more than one piece of redstone of every piece of contraption here. So let's start with this sideways contraption. The easiest way is powering the blocks right next to this one here. Again, make sure that you use immovable blocks wherever slime blocks get involved. But as you can see here, this concept looks rather nice. The same is true if you power it from above with glowstone blocks or other non-full blocks or transparent blocks. If slime blocks get involved, you will have to use hoppers, since those are the only non-movable transparent blocks with the ability to put redstone on top. But as you can see here, they work just fine. But they also make the entire thing a bit more costly or expensive when you're designing greater contraptions. So this is how you can work around those problems here or avoid those piston bugs with sideways contraptions. Now with contraptions that are facing upwards or downwards, you basically should avoid powering them from more than one source. So in this case you should avoid powering full blocks here, so you'll have to use transparent blocks there, and you should also avoid powering blocks in a way that it will activate more than one redstone at the same time. So as you can see here, I'm directly powering the redstone and not the block it's on, and I'm also using transparent blocks here, and again, if slime blocks get involved, you should use hoppers for the entire thing. But as you can see here, this works just like it's supposed to. Also what you should keep in mind is, as I already mentioned, those bugs that appear sometimes are position dependent. So if you design something, it might be a good idea to copy it to another position or a few other positions, for example with an editing program like MC-Edit. So you can see that it works at every possible position, because it's also happened to me sometimes that I finished a contraption and then I found out that somewhere a piston bug is that in some positions appears and in most positions this doesn't appear. So to avoid this, I would recommend playing around with the positioning again. But if you keep those things in mind, this should actually be not a real issue. So now last thing for the mechanical part is talking about tileable designs. Basically there is a mechanic in Minecraft that moving blocks don't count towards the towards the block limit of pistons. So as you can see here, this very first piston here basically has a total of 12 blocks connected with slime blocks. This next piston here basically has those 12 blocks plus those 3 blocks it's sharing with the first module here. So in total it has 15 blocks, which is more than the actual pushing limit. But if I power those two modules with a 1 tick delay, they can work, as you can see here. And this is just because the first module is extended, and during the 1 tick it's extending, or during the time 1 tick later, those blocks are counted as moving blocks, so they don't count towards the moving block limit, and thus the second module is again at only 12 blocks, and so on and so on. Which means that if you build several of those designs next to each other with a 1 tick delay, they don't interact with each other wherever they share blocks. So if you want to build this, you can have a spacing with 1 module every 2 blocks. If you put in some additional blocks, you can have 1 every 3 blocks, or you can even stretch this up to 1 every 4 blocks. So this is basically how you can build tileable designs that share blocks with each other. If they don't share blocks, so for example, let's say you have them with a spacing of 3, like this, and they don't share blocks between the slime blocks, then those are already completely independent from each other, and the timing is more or less up to you. All that has to still be kept in mind is that the timing between those two parts, the analog signal and the pulse signal, must always stay the same, otherwise you might run into a few problems, but more about this later on. And with that, it's time to talk about the control circuit, and for this let's start with the production of the analog signal. The general and most basic idea is using 2 hoppers facing each other with a block and a torch, so that the items are transported from one hopper into the other, and then we get an analog signal out with a comparator. And to make this as fast as possible, we want to use items with a stack size of 16, which means that we get a change in an analog signal every 4 to 5 items being moved, which is around 2 seconds for each item change, signal change, which is actually rather slow if you really need an analog signal, or at least it is much too slow if you want to make them as fast as possible. So, how can you speed this up? Basically, we just use the same contraption as before, but now we're taking an analog signal out of both comparators and using the difference of this, which basically, if we put in the right amount of items, will double the speed of the change in the output signal and give us a signal change every 2 to 3 items or 8 to 12 ticks. So this is the general idea behind this. Now, there is one little problem with this general setup, and that is, as you can see here, when those items are moved out of this block here, out of this hopper here, at some point this will turn off, but if we turn it on, we have to wait a long time until we have a certain amount of items in here until we get the first signal out of here. So this means that in one direction, in this case the turning off direction, it reacts immediately, as you can see here, but for the turning on it needs a very long time. This is a delay you can rather simply avoid, and for this all you have to do is basically invert the output signal with the torch and then run it into the hopper that's feeding into the back of this comparator that's subtracting. And this means that the turning off works at once and the turning on also reacts at once, as you can see here. So now I said that you have to invert the output signal and then power the hopper at the back. This can be done in a variation, in various ways. For example, you can power it from below, as you can see here, or you can power it from above. For example, if you want to put your controlling block with the torch below it, or due to some other reason down there. So this is very variable. One thing I want to mention though is you want to invert the signal that's actually powering the very first piston of the first tier of your mechanism. So in this case, for example, as you can see here, the signal that's powering this block here, which is powering basically the first piston of the first tier, is 1 and then a second redstone line away from the comparator here. So we also want to invert this signal 2 redstone away from this comparator here, which is the reason why the torch is here and not at this block here, or something similar. Just to keep in mind and make this as fast as possible. So that's the analog part done. So now let's talk about the second part of the control circuit, which produces the pulses. And the easiest way to produce those pulses is using a block update detector, which is detecting changes in the analog signal. So for example, as you can see here, every change is followed by a pulse that's going in this redstone line here and then can be used to redirect towards our second tier of the mechanism. For this block update design, a block update detector design, you can use any kind. For example, this rather simple one or this rather simple one. They are pretty much working the same way. And also another good thing is they introduce a delay of 2 ticks between a change in the analog signal and the actual produced pulse, which is perfect for our contraptions, but more about this in a few moments. Now, before we can actually go and calibrate the entire thing, we need one more pulse. And that is, at the moment, this design here produces a pulse after every change of the analog signal. But for the mechanical part to work properly, we need actually an additional pulse right before the first change of the signal. And to do this, we will have to go two ways, or we can go two ways. The first way is actually using a second butt at the beginning here, at the input, or giving the butt we also already have in our contraption an update shortly before we actually start inverting the signal or changing the input signal of our contraption down there. So how can you do this? Basically, in this design I went with a simple piston that's updating the entire thing. So as you can see, I just flick the lever here, get the signal, and then shortly after the input of the hoppers here inverts, and we get our changing analog signal and the following pulses. And of course the same thing works in the opposite direction, and that's basically the general idea. What I want to mention is that you need this repeater here, since after the first pulse we actually need a bit of time for the analog change to happen, or until the first analog change happens, since the first here has to actually change position. So a 4-tick delay is rather prudent to use. Now what can you use to update a piston? One rather simple idea is using another piston, as you can see here. You can also use torches, since they update basically all blocks that are in the vicinity to them. So basically a change of the state of this torch here changes all 5 of those glass blocks around it. And if I put a butt switch, for example, in one of those places here, it will be activated by this. The same thing is true for redstone. For every block it would potentially connect with, or the block in front of the repeater, and of course the block where the repeater is in. Or you can also use some crazy contraptions with slime blocks and sticky pistons, and use then basically this block at the end here to update the piston there, if you can't reach it in any other way. So that's basically what this extra pulse, or where this extra pulse comes from. So now it's time to go into detail and start putting items into those hoppers here. And for this, it would be a good idea to start building at least the second tier of your very first module, if you're going for modular design, and then just put it in a state that the piston at the back of our subtractor is blocked, and then position yourself in a way that you can actually see what's going on over here, and then start putting items in here. And at some point we will get the first extensions, and at some point the last piston will extend, and this is exactly the point where we add 2 more eggs, for example. So we need items with a stack size of 16, as I already mentioned. And once you have done this, you have the optimal setup for this entire thing. Now that would be a point where it would also be a good idea to put full blocks on top, so even if you destroy something at the top, there will not be any extra blocks in here, which would kinda work not in your way. So that's basically how you can calibrate the entire thing, which brings us to our last thing, and this is talking about the timing between the analog signal and the corresponding pulses. So for that, let's assume this is the analog output that directly powers the first sticky piston of the first tier, and also this redstone here updates this sticky piston of this block update detector here. Then due to this detector here, this first pulse or this pulse here will come 2 ticks after this analog signal change. Now for the timing of the entire thing, you have a bit of free room or space to play around with. If you have, for example, another mechanical construction in its vicinity that needs a specific timing for the whole thing to work, you have a bit of space. So you can either use this with the standard 2-tick delay, or you can put a 1, 2 or 3-tick delay in between. If this is the analog output and this is the pulse output for the corresponding second tier. So that's basically the entire timing in a nutshell. Now how did I come up with those timings? Basically, for the extension of the entire thing, this first tier needs 2 ticks until it has moved the first tier piston, which only then can again take an input, for example this signal here. So this is the 2-tick delay in the beginning. For the retraction of this whole thing, actually 1 tick would be enough, except if you have a spacing of 1 module every 2 blocks, since as you can see here, this first tier here gets the power from both sides and one side is delayed by 1 tick. So it gets powered at once, but depowered 1 tick later. So also in this contraption here, the depowering also takes 2 ticks in the beginning. So 2 ticks in the beginning, and then in the end you should maybe note that a sticky piston that gets an 1-tick pulse will be an immovable block for 3 ticks, starting with the pulse itself. So in total we have, as already mentioned, the 2 items as a minimum time between changes, so 8 ticks, minus the 2 ticks in the beginning, and minus 3 ticks at the end. So in total it's a maximum of 3 ticks delay you have to play around with. And that's basically all of that. So let's go back and have a look at the contraption from the beginning. Okay, so now with the mechanical part explained and the logical part explained, let's go and have a short look at the contraption I showed you at the very beginning. So as you can see, it's a very simple design. All I have is a first tier with 3 pistons and a second tier pretty standard with 1 piston. I have gone with a symmetrical setup in the first tier here, with basically 1 redstone line more than actual modules. This was due to a little timing issue of the entire thing, with the last module getting a bit confused with the short pulses of the second tier interacting with the piston here of the first tier in a kinda destructive way. So I had to go with this design, which basically equalized the turning off of the last module with all of the following all of the previous modules. But this is just a little cosmetic thing to mention. Anyway, the contraption, as you can see, is just a very basic one with our analog signal generator down here. I'm using the signal that's powering the first module here, or the first piston of the first tier, inverted to power this hopper here and make this as fast as possible. And then I'm using this torch here basically to power or to give the entire thing the very first pulse in our pulse sequence. And the rest is just a relocation of a lever up to here. And that's basically the entire thing in a nutshell. And with that, you should actually be able to use this concept in your very own contraptions. So with that, I want to finish this tutorial. I hope you enjoyed it, and well, see ya!